Section 7.6, polar coordinates. We're going to plot points using polar coordinates. We're going to convert points between polar and rectangular coordinates. We're going to convert equations between rectangular and polar forms. And we're going to graph polar equations. In the rectangular coordinate system, we have a point in the plane x and a point in the plane y. The x is the horizontal distance, the y is the vertical distance from the origin. In the polar coordinate system, we have an angle, a theta, and then we have a length r. So the polar form would be r, comma, and then your angle. So r is this length, this angle is your theta. Okay? So r is the directed distance from the pole to the point P. There's my pole. This is a polar axis. So it's really the positive x-axis, like if you are going around the unit circle. Theta is a directed angle from the polar axis to the line segment, OP. And O is the point at the pole. Okay, and P is your polar coordinate point, or pole. And like I said, it's r theta. And we can either have it in radians or degrees. Positive angles are counterclockwise, negative angles are clockwise. It's like around the unit circle. So plot the point having the polar coordinates 4, 210 degrees, then find different polar coordinates r theta for the same point, which r is less than 0, and the angle is between 0 and 360, r is less than 0 and the angle is between negative 360 and 0, and r is positive and the angle is between negative 360 and 0. So when you're doing this, if I was just going to plot that right there, I would go 210 degrees around. So I'd go 210 degrees around, and then I would go 4 units out, 1, 2, 3, 4. And that would be the point 4, negative 210. But I want r is negative, so I want a negative 4 and some positive angle. I want negative 4 and some negative angle. And I want positive 4 and a negative angle. That's what it's saying there. That's what I want. Okay? This is the positive direction. That is the negative direction. Okay? So if I want something between 0 and 360, you can think of it as, well, I could just go to here and then go in the negative direction. There's my negative 4. So let's figure out, what is that angle though? Well, that angle there from here to here is 180, so the reference angle is 30 degrees. So one would be, I could go 30 degrees and go negative 1. So there's one. Okay? Another one, you could go, I want a negative 4, but I want a negative angle. So my angle could be negative. Remember, this was 30 degrees that I went to. But I could go this way. That would be 360 minus 30 is 330. So there's that one. Or I could just go a negative angle. So I could go this angle right here, which would be 180 minus 30 would be 150 in the negative direction. And there are my points. And you're done. So you need the 3 points. Example 2 is number 18 on 708. Plot the point having a polar coordinate -2, 3 pi over 4, then give 2 different pairs of polar coordinates of the same point, one with a given value of r and one with r having the opposite sign. So I want one being -2 some angle, and I want the other one being +2 some angle, where it's not the exact same point. Okay? So here's what my graph looks like. I go 3 pi over 4 this way, and then I go -2. Okay? So remember then, if I'm going 3 pi over 4, that would be a pi over 4 reference angle, if you want to think of it that way. Okay? So one way I could do it is I could go that angle. Okay? And that would be negative 5 pi over 4. And then the negative 2. So there's 1. Okay? Another angle would be, I could go this way in positive 2. That's pi over 4. Not the only way to do it. I could also go this way and go 7 pi over 4. So that pi over 4 could have been 7. Oops, sorry. Negative 5 pi over 4. Could have been positive 7 pi over 4. Okay? So those are the different graphs that you could have, or different numbers you could have. And here, I wrote some of them here. Here's some of them that I wrote, but like I said, you could have had the second one being 7 pi over 4 as your angle instead of negative pi over 4. Next example, number 30 on page 708. Convert negative 1, 7 pi over 6 to rectangular coordinates. Remember that cosine of theta is x over r and sine of theta is y over r. Okay? And remember that pi over 6 triangle has sides with a ratio of 1 to radical 3. So don't forget that when you're doing it. This is what the picture looks like. So I can go 7 pi over 6 this way, and then I'm going 1 that way. Okay? So here's what that's kind of what my triangle looks like. I have a reference angle there. You should know this reference angle. If I'm going 7 pi over 6, that's a pi over 6 reference angle. So I know that the cosine of theta is x over r, and r is 1. Cosine of pi over 6 is equal to x. That's what I have written here. When I'm doing this right here, x is equal to r cosine of theta. I could do it that way. And r is negative 1. So just plug in what you know. This is the negative 1. Because the direction was negative, there's my r. That's an r. And the theta that's given is 7 pi over 6. So x is negative. Cosine of 7 pi over 6 is negative radical 3 over 2, which is equal to positive radical 3 over 2. And with the picture, you kind of see that that's what it is. If you label your sides, if you know the ratio, the hypotenuse is 2. It has the same ratio. Let me draw it out. You know that they have the ratio of 1 to radical 3. This is 1. So if I divide all these by 2, this gives me my x, radical 3 over 2. There's my y, but I can do it the mathematical way. Y is equal to r sine of theta, negative sine of, there's my angle. Sine of 7 pi over 6 is negative 1/2. So a negative 1/2 is positive 1/2. But you kind of see the answers from the picture. You could also pick up your calculator, and in the angle measurement, you can do from polar to rectangular. Okay, you can put that in your calculator, and that's under the angle button, which was the same place that you did your degrees and degrees, minutes, and seconds when you converted it, if you remember that you did that. Next one. Convert the rectangular coordinate to a polar coordinate, r theta, where r is greater than 0 and your angle is between 0 and 2 pi. So first of all, we need to find out what quadrant we're in. So if it's negative, negative, I'm in the third quadrant. And don't forget that x squared plus y squared is equal to r squared. So r is equal to x squared plus y squared. And then we can find theta by using the tangent of theta is your opposite or your y side over x. That's an x. Doesn't really look like an x. Okay. Y over x. Okay. Make sure it lies in the same quadrant, the third quadrant. So when we're doing it, like I said, it is in the third quadrant because it's a negative and a negative. R is equal to the first one squared plus the second coordinate squared. Negative 2 squared is 4. This squared is 4 times 3 is 12. 12 plus 4 is 16, which is 4. So R is 4. And then, when you're doing this, tangent of theta is your y, which is negative radical 2 over 3, or negative radical 2 times 3, over your x, which is negative 2. If you put it in your calculator, you get a pi over 3, but that's only telling you your reference angle. I'm in the third quadrant with a pi over 3 reference angle. That is my theta from 0. So that would be then 4 pi over 3. So my r is 4 and my angle is 4 pi over 3. And you could put it in your calculator using the angle button. You can do rectangular to polar. And then put that in and you'll get the rectangular to polar r, that gives you your r. Rectangular to polar theta, you put in your x and y, that gives you your angle theta. And 4 pi over 3, if you put in your calculator, is negative 2.09. Next one, convert the rectangular equation, x cubed is equal to 3y squared, to polar form. Remember that x is r cosine theta, because cosine is x over r. And y is equal to sine theta, because y over r is sine. So instead of x cubed, you're going to put that r cosine of theta cubed. So there is x cubed is equal to 3 times y cubed. Y is r sine of theta. This would be r cubed cosine cubed. This would be 3 r squared sine squared. We want to solve for r. Okay, we want to solve this for r. So we take this equation and we're going to divide each side by r squared. Okay, and if we do that, we'll get r here and that r will disappear. So that's what we did there. Divide by cosine cubed of theta. So that's what r is equal to. And I could break this cosine cubed up into cosine squared times cosine. And the reason I'm doing that is because I have a sine squared, and sine over cosine is tangent, so sine squared over cosine squared is tangent squared. So that's the only reason I'm doing that. So this is my tangent. I have my 3, and 1 over cosine. 1 over cosine is secant. And there's your answer, and I'm done. Next one. Convert the polar equation to rectangular form. Identify the curve. So remember, x squared plus y squared equals r squared. X is equal to r cosine theta. Y is equal to r sine theta. And tangent is y over x. So don't forget that when you're doing that. So I'm going to start with what I have here. I have my r is equal to 4 sine of theta. Well, looking here, I have a sine theta, but there's no r there. So if I multiply each side by r, what I did, I multiplied each side by r. Now I have a y. That's y. So I have r squared is equal to 4y. R squared is x squared plus y squared. I'm going to move the 4y over to the other side. And here, for everyone that doesn't like the trig and likes algebra, we are going to complete the square. So to complete the square, I take half of this -4 and square it and add it to each side. So -4 divided by 2 is -2 squared. And that's also -2 squared, which is 4. This will factor into x squared plus y minus 2 quantity squared is equal to 4. This is a circle with a center of 0, 2, and a radius of 4. This is a circle with a center of 0, 2, radius of square root of 4, which is 2. And you're done. Next one, convert the polar equation to rectangular form. When we do this one, tangent, remember tangent is y over x. And if you have the -π/6, and if you want me to draw it out, I will. There's -π/6, which is a 1, 2, radical 3 triangle. Okay? I forgot my negative sign there. So the tangent of -π/6 is the opposite, which is a -1 over radical 3. So if you take this and you get the radical out of the bottom, you could write it that way if you want. You don't have to. You can take my equation, and like I said, I forgot the negative, because it's -π/6. So that's a negative. You can, y over x is equal to this, multiply each side by x, and there's your equation. Okay? It's a line with a slope of, and it's negative, radical 3/3 and a y-intercept of 0. And you're done. Next one. Sketch the graph of the polar coordinate by transforming it to a rectangular coordinates. So we have r plus 3 cosine of theta is equal to 0. Just doing algebra, solving for r. So that's the first thing I did. So r is equal to -3 cosine of theta. Multiply each side by r. That's the first thing I did. And the reason I did that is because I wanted an x. That's x. So that's x. R squared is x squared plus y squared. Move everything to the one side. And I can complete the square. So half of that squared added to each side. And it factors into x plus 3/2 squared plus y squared is equal to 9/4 squared. I have a circle with a center of -3/2, 0, and a radius of 3/2. And you could put it in your calculator and graph it. Let me just show you on your calculator how you can graph that. So let's get our calculator out. And let's graph one of these polar coordinates. R is equal to -3 cosine of theta. I have my calculator up here. First of all, go to mode. I'm going to put it in radian mode. It'll graph easier. It doesn't really matter, but radian mode will make it, it'll be a lot easier to graph. POL, that's polar. So instead of function, whoops, hold on, quit, let me do it again, mode, down to function, down to polar, there's polar, so push and enter. And now, if I go to y equals, now instead of y equals here, they're the r equals. R is equal to -3 cosine of theta. And then if you hit graph, you might not see the right graph because of the zoom feature. But if I do zoom, and then there should be a zoom fit, that probably will take me to the right place. Let's see. Zoom fit. which is 0. You push 0 if you want. And there it is. 1, 2, 3. There's my circle. It just fit it, so it kind of looks like an oblong, but it is a circle. Okay. And if you want to trace it, you can see, it'll give you numbers, and you can see that this is 0. This will be 3 halves. This will be 3. Okay. This will be 3 halves up. This will be 3 halves down. Okay. So there's the graph of it. And you're done. Next one. Sketch a graph with the polar equation r is equal to 1 plus sine of theta by plotting points. So here, this is just like an xy table. But my x is theta, and my y is 1 plus sine of theta. So now think about the unit circle. Sine of 0. Sine is y over r. Add 0, your y is 0. So here you'll have 1 plus 0, which is 1. A 30-degree angle, your sine is 1/2. So here you'll have 1 plus 1/2. Here's a 60-degree angle. So this is radical 3 over 2. And put it in your calculator to get the 1.866. Pi over 2 gives you 1 for sine. So it's 1 plus 1. And just go all the way around the circle, and you get all your points. So I'm not going to do every one, because I think you guys get the idea of how to get the points. Okay? So I'm going all the way around the unit circle. You can continue going on if you want, past 5 pi over 6 and go to pi, and then go to 7 pi over 6, or you can just go around the unit circle negative. You'll still get the same answers. So what I did is I just did all the angles this way, and then I did all the angles that way. But you could do all the angles to 2 pi. You'll still get the same answer. Okay? So negative pi over 6, when I'm at negative pi over 6, that's a 30-degree angle in the 4th quadrant, so that's why it's negative. And you can do that all the way around. So there are your points. Okay? So now, if you had to graph it by hand, this is from the calculator, you can think of this right here as the x and y axis, and at 0 degrees or 0 radians, I am 1 unit over. So from here to here is 1 unit. So I put a dot there. Okay? If I'm at pi over 6, pi over 6 is approximately, let's see, maybe right about there. So at pi over 6, I'm 1.5 units. So if I go 1.5 units this way, I can put a dot there. So there's my next one. Pi over 3, now I'm a little farther out. From here to here is about 1.9 units. At pi over 2, which is up here, I'm about 2 units away. At 2 pi over 3, I'm about 1.9 units away. At 5 pi over 6, I'm about 3/2 unit away. So those are some points there that I picked. You could pick pi over 4 if you wanted. That's radical 2 over 2. At negative pi over 6, instead of going 1 unit out, I'm about 1/2 unit out. And I'm even closer at negative pi over 3, and at 0, or at pi over 2, I'm at 0, and so forth. And there are my points. You could pick up your calculator and put it in your calculator and see this graph. And let me do that right now. So it's 1 plus sine of theta. So pick up your calculator. There it is. R equals, so that's a y equals, and it's 1 plus sine of theta. 1 plus sine theta. Graph. If it doesn't graph right away, whoops, did I do that right? 1 plus sine of theta, something doesn't look right. Y equals, oh, because I have 1 times sine of theta, theta. 1 plus sine, knew it looked funny, theta. And you're saying, that doesn't look like that. Well, that's zoom. And remember, zoom fit was a 0, so I'm going to push 0. And there it is. There's the graph. So any of these, make sure you know how to graph them on your graphing calculator also. Do them by hand, also do them manually, or do them manually and also do them automatically with your calculator. Okay?